Can you hear me right now?
I hear you.
Okay. Hello, everyone. Welcome to the virtual presentation organized by Karadeniz Technical University Graduate Institute of Natural and Applied Science. Today, our presentation will be about soil magnetics. The program will be presented by our colleague, Dr. Alexander Menshov. He is an associate professor of Department of Geoinformatics of Taras Shevchenko National University of Kyiv, Ukraine. Okay, and after the presentation, maybe we can take a few questions if we have a time. Here you are. The floor is yours.
So I can start, yes?
Yeah.
Thank you. Now I try to start full screen. Do you see now my full screen?
Yeah.
And slides change?
Yes.
Okay. Hello, everybody. So my name is Alexander Menshov. I am from Kyiv, Ukraine. And today we will talk about magnetic studies of soil in Ukraine. I think I have half an hour, yes, more or less. And first of all, I would like to say thank you organizers who invited me to perform this presentation. This really great honor for me. Special thanks to Turgay Dindaroglu because we cooperate during last years in scientific field, and I hope for you, like as a more possibly soil scientist, will be interesting to hear how geophysicists study soil. And I would like to show you the map of Ukraine because the most of all we study soils from Ukraine, of course. What generally I would like to say. Actually, I am not soil scientist. I am geologist and geophysicist. I hope you know that the geophysics is studying of different earth fields, and one of these fields is magnetic field. And to complete this magnetic field, to produce it, every magnetic things from the earth, from the surface are important, and of course soil too. This is the map of Ukraine with the main agroclimatic Ukraine zones. And I'd like to say that in Ukraine we have very different soils, starting from very fertile Chernozem, possibly you know this kind of soil, and finally we have mountain soils in Carpathian Mountains and in Crimean Mountains. We have different sandy soils, poor with organic matter in the north part of Ukraine. And in this slide, you can see the soil map of Ukraine and with the areas which now is under temporary occupation or where some war impact is important now. At the end of our presentation, I will talk about war impact to the soils of Ukraine. We have some main types of soils. I give their names in VRB classification, and with our national classification, maybe you know Sokolovsky classification, I don't know. In any case, the most important are phyrosomes, chernosomes, glaze soils, albusols. And actually, in this map, you can see that we have a lot of kinds of soil. And the most essential for us now is that these soils differ with their magnetic properties. And of course, these magnetic properties could be natural or from some anthropogenic impact, war impact, and even hydrocarbon impact, I mean oil and gas. Here is a table with some comparing of classification of the names of soils in VRB classification and in soil national classification system. Why soils are magnetic? Because you know that soils include different elements and minerals. And at the right part of the slide, you can see the most important magnetic minerals which occur in soils. This is magnetite, magnemite, hematite, goethite, peroxide, greigite, and some other. But this is the most important. Of course, magnetite is the most important magnetic mineral and widespread in soil. What we study? We study different magnetic properties. The most important and very easy to measure is magnetic susceptibility. To evaluate, to understand the overall magnetic signal of soil. But of course, there are other magnetic parameters which are related to magnetic material, to magnetic minerals, and they depend on the temperature, of the magnetic field, from the size of magnetic particles in soil, and all this we can measure. And when we know this, we can say that, oh, here is some pollution, or here is some soil erosion, or here possible is impact of oil and gas deposits. Or we can talk even about landslides which are related to soil erosion. Or possible, unfortunately, that here was some missiles attacks, I mean war impact, bombs, and after this some changes in soils. Here I just demonstrate you some magnetic equipment which can measure magnetic properties. This is laboratory instruments. Of course, we have some field instruments, but at the field it's more for overall recognize investigation, and in the laboratory we can perform more precision measurement. So this is to measure magnetic susceptibility. This is to measure some magnetization. I will not go deep inside magnetic methods because you are not from magnetic community. I will talk mostly about overall description of magnetic parameters related to soils. For instance, this is SQUID magnetometer. This we can measure different types of magnetization in different vectors of this magnetization. This is the best instrument I ever seen for magnetic measurements, magnetic property measurement system, because only this instrument can measure soil in magnetic field up to 7 Teslas. This is very strong magnetic field, very strong. And we can measure at the temperature range up to near 0 Kelvin, absolute zero, and heating up to, I don't know, 1000 degrees. And of course, in different frequencies, all this information gives us data about origin of soil and their changes. Here is some description about what magnetic parameters, what they can demonstrate, what their relation. This could be identification of domain state of magnetic mineral, or identification of some coercitivity parameters and others. And now I will show you several examples of our measurements. Here I start from the main task for geologists, oil and gas prospecting. This is case of our studies in the Carpathian Mountains. What is the idea? The main idea is that all hydrocarbons, oil and gas, which possibly deposits are at the depths of several kilometers, but all these fluids have some migration, and some fluids reach the upper geological horizons and soils, and under their migration they change magnetic minerals, and new magnetic minerals have other different magnetic properties comparing with natural ones. And in this case, we can identify these deposits. This was one case study at the hydrocarbon field. Very interesting place because these hydrocarbons are at the surface, and we could more precision take the samples to see and to measure. This is model of this migration. I told you that from the deposit or reservoir, this fluid goes to the upper parts, and at the surface we can see some magnetic and soil magnetic anomalies. For instance, this is changes of magnetic susceptibility with the depths. The most interesting is that when the soil or underlying horizons, like horizon C or deeper, is mixture with hydrocarbons, in this case, magnetic susceptibility grows. Okay, these pictures demonstrate different temperature dependence of magnetic parameters. For instance, we can identify peritite near absolute zero. All these measurements gives us understanding what kind of minerals are responsible for magnetic enhancement of magnetic susceptibility or something other. And of course, when we are talking about hydrocarbon deposits, we must compare magnetic data with some geochemical data and others. And in this case, these anomalies of some concentration of soil gas at such kinds of deposits They correlate with magnetic anomalies. Environmental pollution, soil pollution. Here you can see the sources of this pollution. That is industry, coal burning, road traffic, all these particles, particulate matter from these sources finally occurs in soil. And unfortunately, the new source of pollution for Ukraine is the military-related heavy metal emission. After these attacks, you can see such kinds of redeposits of soil. For instance, this particulate matter, I think you know, PM10, PM2.5, have effect on organism of the people. So these fine particles can go inside your cells and increase the risk even of cancer. This is magnetic minerals, or the composition with some kinds of heavy metals or other things. This is from scanning a microscope. You can see these pictures. This is case study of pollution in one Ukrainian small city, Truskavets. And the main idea that near the road traffic where pollution increases, the soil is polluted. And you can see that in this map, that anomaly of magnetic susceptibility is higher near road traffic and decrease when we are going to the forest area. Okay, this is again some pictures of studying thermomagnetic analysis. Under heating, we tried to find what magnetic minerals are responsible for these anomalies, and we know that, for instance, if we identify magnetite in multi-domain state, this means that here is definitely pollution. The sources is from pollution, not from natural soil. This again some studies of thermomagnetic parameters. I will not give you interpretation, deep interpretation, because for this you must know physics. This is the same hysteresis loops that gives us information about what kinds of minerals. This information gives us what domain. The domain, this is related to magnetic parts of mineral. And if this multi-domain state, this means that this is pollution. And if this is single domain state, this means that this is natural soil. In this case, the most of samples were in multi-domain or pseudo single domain near multi-domain state. And the most important is that magnetic parameters, magnetic susceptibility, MS, is in correlation with heavy metals content in soil. You can see here correlation with cuprum, plumbum, zinc. Agriculture. How we use magnetic properties in agriculture. For instance, this is a field with Jerusalem artichoke, and we measured the height of this plant and magnetic susceptibility. And you can see that the maps of the Jerusalem artichoke height and magnetic susceptibility have the same configuration. So if the soil is more fertile, more rich with organic carbon, so magnetic susceptibility is higher. But of course, we must take in account that possibly this could be some fire impact, so changes are from the other kind of interpretation, or pollution, about what we were talking in previous slides. This is correlation of soil magnetic susceptibility and Jerusalem artichoke in this case. Here we can see studies of humus content, organic carbon, and magnetic susceptibility correlation. The relation is high. And of course, if we study soils, the genetic horizons like ABC, we can see that the magnetic parameters differ to these horizons, and when we know this distribution, we can see that, for instance, in horizon A, susceptibility is higher and decreasing when we are moving to horizon C. This for another unhysteretic remanent magnetization parameter. Okay, this is again some temperature dependence which help us to understand again the magnetic phases, magnetic minerals. Landslide assays. You know that the initial point of landslide formation is soil water erosion, and if we find with magnetic methods this soil erosion, we can say about landslide. This is one case study in Kiev. Here is like a lake with widespread soil erosion, and the main essential is to identify a redistribution of soil horizons. For instance, if at the depth there must be horizon C, we identify horizon A with terms of magnetic parameters. This means the redistribution, and this is possible the starting of erosion was our measurements, and here we can see that at the depth of 150 centimeters we can see even in 1 meter depth we can see the increase of magnetic susceptibility, which is related to redistribution of soil with other magnetic parameters. And so we, at this time, at this lake, we identify some polygons which are related to erosion processes. And of course, I would like to say several words about war impact. Now we are working in a project quantifying magnetic properties of soils to evaluate sustainable hazards from heavy metal pollution due to military activities in Ukraine. This project is supported by Polish and United States Academy of Science, and we have our team of persons who works in this program. Our leader, Ksenia Bonder, is in Polish Institute of Geophysics, and other people who have no opportunities to go abroad, unfortunately, we are working from Ukraine. And here you can see different types of sources of the military related heavy metals emission to Ukraine soils. some missiles with characteristics. The initial study area, we started our investigation from Kiev region. We identified soil types which were impacted by these attacks. We identified former occupied areas in Kiev region or areas which are subject for missiles attacks now. And this is results of these attacks, where we try to study heavy metals pollution. Of course, first of all, here must be studied if there is no some other bombs here. This is our field studies. We measure it, these soils in these craters, and we found two types of pollution. The first type is micro level, which related to these heavy metals or other things, but of course there is a macro level which is related to some metal particles, big particles from missiles, from bombs. And our magnetic studies, for instance, magnetic field studies, gives us information about distribution of magnetic anomalies at the agrarian field, which are related to these attacks. Here we can see some anomalies, their intensity from these craters. And when moving like through the catena, some transection which cross some craters and not disturbed field, we found different anomalies. Then we take these samples and from anomaly zone and natural zones to measure heavy metal content and to understand if we can use this soil in the future for agrarian production and other. Actually, I think this all what I want to introduce you today, because this was like a brief analyzing, brief presentation of different fields where we apply our magnetic methods when studying soils. So I would like to say thank you for your attention.
Thank you very much, Alexander. It was a really interesting presentation for me. I know that it is really difficult to carry out scientific studies under the war conditions. Congratulations. You didn't stop. You try to continue to make a scientific collaboration also. Thank you so much for this. Yes, I think it's time to, if possible, we can get a few questions from our audience. Is there any question? Yes, maybe I want to ask something for you, Alexander. Maybe my question will be about radionuclide concentration in soil and their monitoring process. Is the soil magnetic methods successful in detecting and monitoring natural or artificial radiation fallout? Do you have any experience?
Thank you. Look, of course, radionuclides occurs in soils. Soil contains some radioactive elements. But the instruments and physics of the process is different. I mean that magnetic mineral is not radioactive. And of course, radioactive elements are not magnetic.
Yeah.
So if, for instance, if it's some power plant working, yes, and under some production of something, at the same time are produced and radioactive radionuclides, and at the same time produce magnetic minerals in some matter. So it's possible to use all these methods together.
Okay. Maybe another question about some relationships with the soil fertility or soil quality. What do you say about this?
Soil fertility and soil quality, or for sure, this is very strong relation, because in most cases, magnetic susceptibility have correlation with erosion parameters estimated from equation USLE, RUSLE, yes, and or organic carbon content have correlation with magnetic susceptibility, or even some others important for soil fertility elements like nitrogen, phosphorus, potassium, yes. So that is why we can use magnetic method in agriculture land, because to be successful we must have some relation or correlation of magnetic parameters, because for agrarian are not interested in these magnetic minerals. For agrarians is interesting fertility or erosion, yes. We have this correlation, and this is the main idea why we use our study.
Okay, thank you. Any question from other attendees about the soil, the magnetic properties and relation others? If not, maybe we will finish. Thank you very much, dear colleague, Dr. Alexander. We have accomplished very valuable work together, and our cooperation continues. And I hope after the war we will get a strong collaboration between among universities. Thank you so much for join us, and see you soon. I think if any last word, if you have.
The main that thank you a lot for my invitation. This was great to be in very well-known international scientific community and to present the results, especially this time when I cannot unfortunately travel a lot, but this was like traveling to university. And thank you for the invitation. This was a really big honor for me, and I hope for our next collaboration, fruitful collaboration. Thank you.
Thank you very much.